Can statement for this lesson is listed right here. I can add and subtract numbers in scientific notation. There's not a lot of unknown words in this I can statement, but just want to remind you that scientific notation is a multiplication expression of a number. What do I mean by that? Well, for example, the number 2 can be written just as 2, or I could write it as 1 times 2, or I could write it as 2 times 1. And all three of these different expressions express the number 2. Well, scientific notation is just a form of an expression that expresses a single number. And so I could say, okay, 2 times 10 to the 0 power, because 10 to the 0 power is 1, that still equals 2. And so this is just an expression of a number in scientific notation. And so when we talk about numbers in scientific notation, we are going to get to some vocabulary here real quick. We have a multiplier, or the number on the left that's being multiplied by a power of 10. And I'm going to give us a better example of a scientific notation, one that is maybe more common to see, something like 3.2 times 10 to the 5th power. So make sure you get this I can statement written down, and I'm going to go over some of the vocabulary. In this scientific notation right here, 3 and 2/10 times 10 to the 5th power, the 3.2 is the multiplier. That's the number that's being multiplied by a power of 10. The base is part of a power, and it's the larger number that we call the base. The exponent is that smaller number, or in this case the 5, of the power. So this whole thing, 10 to the 5th, the whole thing is called the power. The base is 10 and the exponent's 5. In scientific notation, we can add a multiplier to a power of 10 and get ourselves an expression. So anyways, that's our I can statement and the vocabulary for this quick video. We're going to talk about how to add and subtract numbers in scientific notation. Here's example 1. And I'm going to show you 2 methods to do a problem like this, and I'm going to show you 2 methods to do a subtraction problem. At the end of the day, I don't care too much which way you choose to do it. I just hope that you understand both ways. So the first step, if you're going to add numbers in scientific notation, is to convert one of the powers of 10 to match the other. In other words, this is a number plus a number. And in this number over here on the left, we have 10 to the 5th power. Well, in this number over here on the right, we have 10 to the 7th power. Now, we can't just stack these and add them. We can't just go 3.2 times 10 to the 5th plus 5.1 times 10 to the 7th. The reason we can't do that is these powers of 10 represent the place value of our multipliers. And so what I mean is, in this number, 3.2, we'd move the decimal point to the right 5 times, but in this number 5.1, we'd have to move the decimal point to the right 7 times if we were to convert these to standard form. And so the decimal points, I mean, they wouldn't add up. Let me show you. So this would be 4 zeros here, I think. 1, 2, 3, 4, 5, yeah. And we had the 5.1 underneath the 3.2 over here, but we'd have to move it 7 times in this case. So 6 zeros, 1, 2, 3, 4, 5, 6. And you guys know we can't add numbers this way because our place values aren't lined up. I mean, the 1s are here, the 10s are here, they're not lined up. So that's a problem. So the first thing that we want to do is convert one of the powers of 10 to match the other. And so we can't do it this way. So one way that we can do it is we can decide to make one power of 10 larger or one power of 10 smaller. I personally like to take the smaller power of 10 and make it larger. So I'm going to take this 3.2 times 10 to the 5th, and I need to figure out question mark times 10 to the 7th. I need to figure out a way to make this number equal something that means the same, but move the power of 10, move that exponent from 5 up to 7. Well, this is the way I like to think of it. This whole thing right here is a number. I need to make this part of my number larger. So if I want to make that larger, which I did over here, I need to make this part of my number, the multiplier, smaller. Why would I need to make the multiplier smaller? Because I made the power larger. And I don't want to rewrite a number on the right-hand side here that means something different than the number on the left-hand side. I want them to mean the same thing. So in this particular case, if I make my power of 10 larger by 2, I need to make my multiplier smaller by a factor of 10 to the second. So I move the decimal to the left twice. In other words, I can say this number is 32 thousandths times 10 to the 7th, and I can say that means the same thing as 3.2 times 10 to the 5th. Because I made the exponent on my power of 10 larger, but I made my multiplier smaller by a factor of 10 to the second, or 10 to the negative second, depending on how you want to say it. So that's one way we can do it. And now that we're at this step, the second step, after we've converted them, is to add the multipliers. And then the third step is to write the number as a product of the power of 10. In other words, here, I'm going to come back here, I'm going to add the multipliers, 32 thousandths plus 5 1/10. The reason I'm going to add 32 thousandths is because I converted this number to become this, so that my powers of 10 would match, and so I still have this original problem here. So once your powers of 10 match, your place values are lined up and you can add the multipliers. So 0.32 plus 5.1. And if we do the addition, I ran out of room, so I'm going to have to write the answer over here. We get 5.132. If I did that right. We had 5.1. Yep. And so now the last step is to write that number as a product of our new power of 10, which was 10 to the 7th, because that's the power that they have in common. This video is about over. I just want to do one more example problem with you, or I'm sorry, I want to do the same example problem with you a different way. So this was the first way you could do it, okay? But if I had the same problem and I wanted to attack it in a different way, the other method you could use is to convert both numbers into standard form. And then I'll do that really quick. So convert them both into, like, your regular standard form of a number. In this case, add. This works for addition and subtraction. Add the numbers. So 320,000 plus 51 million. And then the third step would be to write the answer, or the sum, in, whoops, spelt that wrong, 1 second, in scientific notation. or 5.132 times 10 to the 7th. And notice this answer, 5.132 times 10 to the 7th, matches the answer we had back here. We just did it in different ways. This method is the easiest to understand but takes the most work. You have to convert twice. This method over here, once you understand it, what you're doing, you're converting one of the powers of 10 to match the other, then you can just add the multipliers and move on from there. Like I said, I don't care which way you do it. I just hope that you come out with the correct answer at the end. This is perhaps, like I said, the most easy to understand. I was going to do one more example problem, but the video is getting kind of long here, so I'm just going to say this last thing. If I had a problem like 3 and 4/10 times 10 to the 5th minus 4.1 times 10 to the 3rd, you could approach this problem in exactly the same way that I showed you before. The only difference is when it came down to, like, after you had converted this to have the same power of 10, so like after you convert it to this, the only difference is you subtract the multipliers instead of add. So addition and subtraction are done exactly the same way, except when you add, you have to add the multipliers. When you subtract, just subtract the multipliers. Unless, of course, you're going to use that second strategy, which is to just convert them both to your regular standard form of a number and subtract that. So anyways, I hope this was clear enough. This is not always the easiest thing for kids to understand, is how to convert a power. Just remember that the only way I was able to convert this so fast to make this a power of 10 is I thought, okay, I'm making this part of the number bigger, so I have to make this part of my number smaller to keep it even, to keep it the same. Anyways, good luck to you. I hope it goes well.